Hey guys, this is 6.5, my example 3. Let's get started. First thing is we're doing even frequency rose curves. B's frequency, you can fill that in. We are graphing R is equal to 4 sine 2 theta. So instead of getting a circle like we did before with the previous example, we are looking at something with a frequency that's not just 1. Let's get started. To do this, we need to first understand the rectangular 4 sine 2 theta. So let's graph that. Y equals 4 sine 2 theta. It's a horizontal shrink of half, and there's 2 of them from 0 to 2 pi. So I'm going to graph 2 full sine functions, 4 sections each. Starts at 0, goes to its max, 1, 2, 3, 4, back to 0, to its min, back to 0, to its max, back to 0, min, back to 0. These zeros are going to be important in this graph. Here's a 0 there. Whoops. Here's pi. Here's 2 pi. This is pi over 2. And this is 3 pi over 2. Those zeros are important because when we talk about if they're these sort of asymptotes, they're more guidelines to help you draw the petals of the rose curve. But basically, from here to here, that's going to be a petal. And from here to here, that's going to be a petal, because when you draw the curve, this is where the pole is. This is where the pole is. This is 4 units away from the pole, and this is going back to the pole. So away from the pole, back to the pole. You're going to end up drawing a petal. Now, to demonstrate this kind of in a more visual sense that's more tangible, I got a little thing going on here on the side. There was one day I was just imagining, how I can do this in a more tangible way, and this just popped in my head. So hopefully this helps some people. You got sine 2 theta here, and here, from here to here, right? That's your x-axis or your polar axis, however you want to think about it. So this is from 0 to 360. Oh, this is backwards. Let's flip that where it's inverted. All right. So from 0 to 360. Now, this represents the angles, right? And in a polar graph, the angle is circular. The angles are circular versus linear. So basically, if I can condense the x-axis here, it can represent the polar better. So let's do that. And there you go. This is roughly how you can sort of understand the concept of polar, right? You have a linear axis here, but you take that linear axis and make it circular or radial, right? And basically, that's how each one of these peaks and mins, right, maxes and mins, become the petals of a polar graph. And hopefully, I don't know if this existed anywhere before, but hopefully this helps you guys sort of understand what's going on. Now, the order in which these petals correspond with, this is quadrant 1 and this is quadrant 2 and so forth, that doesn't match up with the way it's actually drawn. But hopefully that still gives you sort of an understanding of how this axis is the same as this, okay? So here we go. From 0 to 2 pi, I start at 0, I'm at the pole, and I go away from the pole to 4 units away and back to the pole. So that's 4 units away and back to the pole. Now, to help me draw, we're going to fill in some of these characteristics. So maximum petal length. Now, 4 sine 2 theta, the maximum value of it is 4, so that's 4. Number of petals. Well, I see that there are 1, 2, 3, and 4. So let's go ahead and put 4 there. And just think about this. If you have a sine function, you're going to have 2 petals. So 2 sine functions will have 4 petals, all right? Angle in between petal tips. So if you have 2 pi radians and you have 4 petal tips, it's just 2 pi over 4. Whoops. And that's just pi over 2. So 90 degrees in between petal tips. The symmetry in this case you will see is over x and y axis plus origin. Now, originally in the previous example with sine theta and cosine theta, we did say that I wanted you guys to remember that sine always is symmetrical over the y-axis and cosine is symmetrical over the x. It's still true here. It's just that it's x and y. But for the odd ones, it's only going to be the y-axis for sine. And for the cardioids, it's only going to be the y-axis for sine and x for cosine. So that still holds true in those other ones. Here, it's x and y. So let's go and graph this. First thing we're going to do is, we have to write the asymptotes. So the asymptotes are going to be at theta is equal to 0, pi over 2, pi, 3 pi over 2, 2 pi, and it can actually keep going, but to be honest, like the asymptotes are more like helpful guidelines to draw it. They're not actual, the asymptotes we think where things don't exist. It's just that when we're sketching it, it really helps. So the reason why we put them in there is because if you think about it, at 0 and pi over 2, the petals, they're being drawn in between them. So if I go from 0 and now I'm going to extend it through the origin, that actually covers, the guide, the drawing guide or the asymptote here of 0 and pi. So you didn't actually have to write 0 pi over 2, pi, 3 pi over 2, and so forth. You could actually do a few of them and realize that they're going to cover other ones. And usually if you draw a few, you're going to start seeing them just come together. Pi over 2 is over here, but if I extend it through the origin, I'll cover my 3 pi over 2 and then 2 pi, and you get the idea. Now let's start sketching this. Now notice this maximum right over here, that is 4 units away from the pole in the direction of pi over 4. That's right here. So I'm going to label this A. I'm going to label that A. Okay. Over here, notice from pi over 2 to pi over 2 to pi, right? We're right over there. We are now 4 units away with a negative radius. Well, that's 3 pi over 4 in this direction, but we're going negative, so we're actually going to be going this direction. So that's going to be over here. Let's label that B. Over here, this is C, and obviously that's from pi to 3 pi over 2. So pi to 3 pi over 2, that's in quadrant 3. That's going to be 5 pi over 4, 4 units away. I'm over here. That's C. And then finally, D is going to be over here. That's a negative. And so instead of drawing that in quadrant 4, that's going to be a negative radius would end up going 3 pi over 4. And that's your D. Now, what's interesting is the way it's drawn. Because remember how I said that little crumpled piece of paper thing I did? The order is not the same. Well, this is how it goes. So try to follow along here. When I first do this, 0 is at the pole, pi over 2 is at the pole. So between 0 and pi over 2, between here and here, I need to go to its maximum and back. So to its maximum and then back to the pole. Now in quadrant 2, this is quadrant 2 here, and this is quadrant 2. I'm not going to draw that petal in quadrant 2. I'm going to draw it in quadrant 4 because it went backwards, right? It had a negative radius. And watch, it's going to go at 0, then to the pedal, and then back to the pole. Then now I'm in quadrant 3 where I have a positive radius. So again, I'm going to go out and then back to the pole. And then quadrant 4 is negative. And so instead of drawing quadrant 4, it goes to quadrant 2. Out to the maximum value and then back to the pole. And so if you take a look, it curves like this. So this part is drawn this part. This part is now this part. This part is this part. And then this part is this part. And that's a polar rose curve.